Okay, and we're going to start. So, coincidentally, this is what we're doing today. That's a few levels above us. Let me get. So it's like some sort of differential equation, series solution kind of thing. Main order for today is to get through that handout that I gave you guys last time. So, I mean, if we finish a little bit early, which depends on how many questions there are, I'll just stop it there because the next topic is going to kind of have a slightly new feel to it, and I just want us to have a clear mind when approaching. It should be a lot of fun. But, so we're going to complete the handout. Problem 1. So we have A equals 1, 2, 2, 1, 0, 1, 1, 2, 1. Find A inverse. B. Use it to solve the system x plus 2y plus 2z equals 1, x plus z equals 1, and x plus 2y plus z equals 0. Okay, how do we start? Augment with the identity. So 1, 2, 2, 1, 0, 1, 1, 2, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then now?
I subtracted row 2 from row 3 and put it in the second row.
What do we do with the first row?
Leave it.
Yeah, in general, leaving it would be a nice thing because it already has the leading 1 here. But I'm actually going to, I'd rather swap it with row 2 first. And the reason why is because I know where I'm going to want to end up. I know eventually there's going to be a pivot right here and I'm going to need a 0 on top. So this is an easy way to kill 2 birds with 1 stone. So I would probably move row 2 up here first, just in anticipation of where we're going to go. But yeah, now we can start subtracting rows. I know that in the very next step I want zeros here and here. So where can I get that from? I can say 1 minus 2 is what was suggested. 1 minus 3 was suggested. This minus that would give me 0. This minus that would give me 0. This minus that would give me 1. This minus that would give me 1. This minus that would give me 0. This minus that would give me 0. And another one. You do something like, so here I used row 1 and row 3 to get this line. So I'm going to use 2 other rows to get a 0 here. What do you want to do? Maybe 2 and 3? I guess could be something we can do. So something like row 3 minus row 2. This minus that gives me the 0. This minus that gives me the 2. This minus that gives me the 0. And this minus that gives me the 0. This minus that gives me minus 1. This minus that gives me 1. What we can do now.
Swap 2 of
I can swap 2 of these to get the pivot here.
you also have the 0, 0.
I can also get a 0 here. So I'm going to do row 1 minus row 2. This minus that, 1. This minus that, 0. This minus that, 0. This minus that, minus 1. This minus that, 1. This minus that, plus 1. I'm going to swap row 2 and row 3. And I know eventually I'm going to divide this through by 2 to get this to be a 1. And actually the second row is in perfect condition for the last spot. And so now, one more step just to get this into the right form. Just divide row 2 by 2. 1, 0, 0. Minus 1, 1, 1. Then I'm going to have 0, 1, 0. And here I'm going to have 0 minus a half. I'm going to have 0, 0, 1, 1, 0, minus 1. So So this means that our A inverse is equal to minus 1 over 1, 0 minus a half, 1, 0 minus 1, and it feels kind of hot in here. Did anyone get this?
Yeah.
Did you get it 1, 2, 3 steps? 4 steps? Okay, 5 steps? Anyone did more than 5 steps? So on a test, like I wouldn't ask you something to go more than 4 or 5 steps because I'd have to grade it. So I'm gonna give you I'm gonna give you some you can get it done in like 3, 4, or 5. If you're taking longer than that, you're probably being inefficient somewhere or just taking it too slow. And yes, you're doing a lot of arithmetic operations here, so the chances of making an error are there when you try to do 2 things at once. But on the other hand, I think you have a higher chance of error the longer you're doing this for. If you're taking 8 steps to do something, that's a lot of opportunity for an error to creep in there. So you do want to be as quick as possible. Try to aim for 3 or 4 steps. 5 if it's particularly crazy, but I wouldn't really ask you something that takes longer than that. So now, for B, we saw last time that if AX equals B and A inverse exists, then we can actually find the X by taking A inverse times the B. So since we just found A inverse, I know that X, which in this case is going to be the solution matrix X, Y, Z, is going to be equal to the A inverse times the B. And the B is the constant matrix. That's going to be the column matrix on this side, 1, 1, 0. So now I do matrix multiplication here. So it's, I need more space here. Minus 1 times 1 plus 1 times 1 plus 1 times 0. And then 0 times 1 plus minus a half times 1 plus a half times 0. And 1 times 1 plus 0 times 1 plus a minus 1 times 0. So that becomes, squeezing in here, 1 minus 1 plus 1 is 0, 0. And here I would have minus a half. And here I would have 1. So my X is 0, my Y is minus a half, and my Z is 1. And of course what you would want to do here is you want to check that. So if I were to take the 0 for the X, so that's 0, minus a half for the Y, so this would be minus 1, and 1 for the Z, that would be plus 2. I do get 1, so that works out. If I have 0 here, plus 1, I do get 1, so that works out. If I have 0 here, Y is minus a half, so this would be a minus 1 here, and that would be a plus 1 there. I do get 0, so that's actually right. Now if I went and I checked this and I realized that, oh, I'm not getting the right numbers, it means I probably made a mistake somewhere here, and that's where I'll start to look back at these things that I wrote down to kind of track my movements, and I'll check if what I was doing actually made any sense. So here I just swapped row 3 and row 2, and here I took row 2 divided by 2. So that's why it's nice to actually leave these little messages to yourself here. In case you realize that there's an issue, you can go back and you can actually look at what might have gone wrong. Then you might check also here to make sure that you actually did the multiplication correct. But in this case, it all worked out. Any questions on this issues that we had? So that was problem 1. So I'm going to ask you a problem like this on the first test. Find the inverse of a 3 by 3. Maybe use it to solve an equation. Problem 2. You want the reduced row echelon form of this is part 8. 1, 2, 3 minus 2 minus 1, 1 minus 2, 3, 2 minus 1, 3 minus 7. Okay. So we remember our goal for the reducer echelon form. We want the pivots. I know it's going to be in this position, but it means I want zeros here and here. And then I'm going to get the pivot in this position, get a 0 here, and then continue from there on. Here I already have a 1, so I'll probably leave that alone. Copy back to a 1. But I know I immediately want zeros here and here. So now I'm going to think, how can I get those zeros? Here I have a plus and a minus 1, so I think just adding these two would work. This plus this, 0. This plus that, minus 1. This plus that, 1. This plus that, 1. Then to get a 0 here, I'd probably multiply this by 2 and add it to that. So it's row 3 plus 2, row 2. This plus 2 times that, 0. This plus 2 times that, 1. This plus 2 times that, 1. This plus 2 times that, minus 1. Is that correct?
Would it be negative 1? After the 3 plus 2 times negative?
Right, 2 times that is minus 4, so that's a minus 1. So I know I'm going to want a pivot here and a 0 here, so I know that's the goal to kill that guy in the next phase. So let's do this. 0, 1, minus 1, minus 1. Let's do row 2 times minus 1. And then I can just add row 2 and row 3. This plus this, 0, that plus that, 0, that plus that, 0, that plus that, 0. I get a row of zeros here. The next order of business, though, for reduced echelon form, I need to kill that minus 2. So I can actually do that by saying row 1 plus 2 times row 2. We'll do that. 1 plus 2 times 0 is 1. Minus 2 plus 2 times 1 is 0. This plus 2 times that, 1. This plus 2 times that, minus 4. And then this is actually fine. And then that's actually fine. So that's the reducer echelon form. All rows have zeros to the bottom. First non-zero number in each row is a 1. All the ones have zeros below them. And on top of that, they also have zeros above when possible. So that's reducer echelon form. Goes on to B. Hence, find the solution to the system x minus 2y plus 3z equals minus 2 minus x plus y minus 2z equals 3 and 2x minus y plus 3z equals minus 7. And of course, the idea here is if I were to augment this system, it would look exactly like this matrix. Except I would put a line here, here, here to represent the equal sign, but nothing else would have changed essentially. And then this system would reduce to that. So remember what we did first. You want to notice where the pivots are. Here's the x column, there's the y column, there's the z column. Notice x has a pivot in its column, which means you can solve for the x. Y has a pivot in his column, which means you can solve for the y. Z does not have a pivot in its column. So that's the first thing you do. Find who does not have pivots in their column. These guys are going to be the guys you can't really solve for. These are your free variables. Set them equal to themselves. That's going to be the first thing. Sometimes people set them equal to other letters, but for now, let's just keep it calling itself. So here, Z does not have a pivot, so I'm going to set Z equal to Z. That's going to be what that guy is. And then you solve for all other variables in terms of them. Remember, you start from the bottom row moving up. Row 3 gives us no information, so we start at row 2. In row 2, I would have y minus z equals minus 1, which means that my y would be z minus 1. And in row 1, I have x plus z equals minus 4, which means that my x would be minus z minus 4. Sometimes, and I'll do this because I think in some of the work problems they require you to write the answer down in a similar way like this. Another common way to express this is to write the answer as a coordinate. Say that x, y, z would be equal to minus z minus 4, comma, z minus 1, comma, z. And then you can say your z is a real number. It can be anything it wants. So an infinite number of solutions here. And one thing you can do is, here's a quick check. It's not comprehensive, but usually shows you didn't make a mistake. I probably, one thing you can do is you can actually plug in this expression minus z minus 4 into x, plug in z minus 1 into y, and then leave z as itself, and it should all actually work out to give you minus 2, 3, and 7. Sometimes that might be a little bit annoying though, so what you can do is choose a value for z and check that. So something like, if I set my z equals 0, that automatically would make my x equals minus 4 and my y equals minus 1. And those three particular numbers should work. So here, if I have minus 4 plus 2, I get a plus 2. And then minus 4 plus 2, I get a minus 2, plus 0, get minus 2, so that actually works out. And then if I plug in here, that would be a positive 4 minus 1. That gives me 3 minus 0, that's 3, so that checks out. If I put in here negative 8 plus 1, that's negative 7 plus 0, and that's 3. So sometimes you'll be off if the coefficient of z wasn't correct, but usually if you plug in a random number, these random numbers actually work out, you probably did okay. So that's just a good thing. Questions on this one? So this was an infinite solutions case. We know it's not unique case because in the unique solution case, each variable has a pivot. Here that was not the case. It was also not the case that we had a bunch of zeros and something that's not zero here. That would mean no solution. That's the only way that you can see no solution. we ended up with a solution that was not a matrix that was not inconsistent, but at the same time, not every variable had a pivot. That leads to infinite solutions. These are the only three cases we need to know about. They're the only three cases that can exist.
So you would recommend just guessing and checking until you get it?
For guessing and checking around.
Or finding Z?
Yeah, just plug in a random number and see if that random list of three numbers actually works out. If it does, chances are you're right. But yeah, it'll still work if you plugged in these entire expressions there, but then you need more algebra to actually get through it. So if you're like in a rush, it's a test, so 5 minutes left, you want to just do a quick check to see, okay, right? This works out, 99% chance you were right. Any other questions about this situation? Okay, so the other two are word problems, and the third one is massive. Let's actually let's hold off on that one. Maybe I should have started over here. Let's actually do problem 3 first, just as a warm-up. It has less variables than problem. Let's do problem 4 first. As a warm-up, it has less variables than problem 3. So I think for this one, it's nice to actually sketch a picture so you can actually see what's going on. I think, at least in one other course, you guys will see pictures like this all the time. But it's a supply and demand scenario situation, right? It can be scary, but don't be afraid. You'll survive, I promise you. Okay, so usually you want to put price on the horizontal, and on the vertical you put either the supply or the demand. In this case, I'm going to put both. Let's put supply in green and demand in the pink. If you don't have colors, that's fine. I would just make sure that the things you're plotting use different symbols. You might use dots for this and then X's for that. But since I have the colors, I'm going to use the colors. So let's actually look at what this is saying here. So we have two prices that are being mentioned here. There is the 480 and the 510. So at 480, the annual supply of soybeans in the Midwest is 1.9 billion bushels. The annual demand is 2 billion bushels. When the price increases to $5.10, the annual supply increases to 2.1 billion bushels and the annual demand decreases to 1.8 billion bushels. Assume the price supply and the price demand equations are linear. So we're looking at straight lines here. So let's actually look at the supply. Look at one at a time, that's how we do this. So at the 480, the supply is what? 1.9, right? So put 1.9 at 480. That's is. Once it's 510, the supply increases to 2.1. 2.1. That occurs at 510. Then we look at the demand. Okay, so at 480, the demand is 2 billion. So that's over here. And at 510, the demand decreases to 1.8. And we're assuming these are linear, so this is a straight line going through. And then that's a straight line going here. Part C says to find the equilibrium price. Where would that occur? At the intersection, right? This point here is called the market equilibrium point. So basically, this is a pretty typical supply and demand graph in the sense that it obeys the law of supply and demand, which basically says as price increases, supply will increase. As price decreases, demand. As price increases, demand will decrease. That kind of makes a lot of sense if you just think about it. So if someone is like, if I'm a supplier of iPhones and someone says, oh, you know, I'll pay you $5 for every iPhone you make me, I'll be like, I guess I can make you a couple, you know, I'm kind of busy this weekend with the kids. You know what, I'll pay $1,000 per iPhone. I will have 5 million of them for you by next month, right? The higher you can charge, the more you're going to want to produce because you increase your profits that way. Whereas, conversely, the demand is describing what the public demands. So if you sell something for $4.80, more people will be able to afford it than if you sell it for $5.10. So there's what consumers are willing to pay for a certain amount of product and what suppliers are willing to supply for a certain amount of product. Now, once these things diverge, no one wants that because in this case there's scarcity and in that case there's overabundance. We have products that no one's buying. So the sweet spot is when both of these converge. You have a price that suppliers are willing to supply the product at, and at the same time the public is willing to consume that many products. And so everyone's kind of happy. This is called the market equilibrium. So this is in the business class, so I'm not going to say more than that. But you need to know at least that to be able to solve this problem. So A says to find the supply equation. We want to know the equation of the green line. B is to find the demand equation. And C is to find the equilibrium price, which is going to be where that intersection is. So let's actually worry about that. So let's look at the supply equation. How do you find that? Yeah.
Find the slope.
Find the slope, which means you're going to try to use y, rise over on like a y2 minus y1 over x minus x1 thing. What you can do is you can pick your, who's going to be the y, x1, y1 and the x2, y2. So let's say I pick the first price. This is the 480, and that corresponds to 1.9. And at the 510, that corresponds to 2.1. So the slope is going to be y2 minus y1 divided by x2 minus x1. And what did we get here? What did we get for the slope? 2/3. Okay. And so we can use the line equation y minus y1 equals mx minus x1. That's y minus 1.9 equals 2/3 x minus 4.8. So this becomes y minus y would equal to 2/3 x minus 2/3 times 4.8 plus 1.9. So that's y equals 2/3 x. And what's this over here?
Negative 1.3.
Huh?
Minus 1.3.
Minus 1.3 is what it comes out to.
Yeah.
Okay. So let's actually make that a little nicer. Notice if I multiply this by 10, I can get rid of the decimal point. If I multiply this by 3, I can get rid of the fraction. So what I'm going to do is multiply by the LCD of both of those, multiply by 30. What I would obtain there is going to be 30y equals 20x minus, multiply this by 10, I would get 13, multiply by 3, 13 by 3 is 39. So I can have something like 20x minus 30y equals 39. This is my supply equation, where x is the price for supply y. Okay, so the x coordinate is my price. For b, I'm going to do something very similar. Set my x1, y1, my x2, y2. So at 480, the demand is 2. And at 510, the demand is 1.8. So your slope m is going to be y2 minus y1 over x2 minus x1. What was that? Negative 2/3? Okay. And so now, are we done with over here? So now I have y minus y1 equals x minus x1. Y minus 2 equals minus 2/3 x minus 4.8. I would get then that y equals minus 2/3 x plus 2/3 times 4.8 plus 2. And this is 5.2. Bless you. And again, multiplying by 30 seems like a nice thing to do here. So I'm going to do that. So I would have 30y equals, 3's would cancel, minus 20x. Here, multiplying this by 10 gives me 52. 52 times 3 is 156. So my demand equation is 20x plus 30y. 156. Where x equals price for demand. Okay. So now, of course, the equilibrium situation happens where these two guys intersect. So I actually want to solve a system of equations to answer the last problem. And so we can jump right into there. I was saving this for so long. For C, we need both equations to work at the same time. So that means I have to solve a system of equations. So I'm going to have something like 20 minus 30, 39, and 20 plus 30, 156. I can say take 2 minus row 1, 20 minus 20 is 0, this minus that is 60. And 156 minus 39 is going to do what? 115? And so from there, I can say 60y equals 117. So my y is going to be 117 over 60. And some of the digits here is 9, so 3 definitely divides into that. So 3 into that is going to go 3 times remainder 2, so that's 39 over 20. Can we do anything else here? $39 is 3 times 13. That's nothing. Give me that as a decimal. What's that? 1.95. Okay. And then what I would have here is that 20x minus 30 times 1.95 is going to be 39. So my x is going to be 39 plus 30 times 1.95 all over 20. And that's going to be what?
4.88.
1.88? 4.88. And so what we end up with this and that. This here was at 4.8, and we had some points here at 5.10, and we found that the equilibrium price is actually $4.88, and the equilibrium demand 1.95 BA. So basically what we're saying is that the best situation for this product occurs at when we're selling it for a price of $4.88, and at that point people will demand 1.95, and I can reliably produce 1.95 billion bushels. I know that it'll all sell if I sell it for 4.88. And a lot of times this is how market research is kind of done. You throw a new product on the market, but you kind of test the waters. So in this place over here, sell it for $4.80. Over there, sell it for $5.10. See what the consumer reaction is. You'd be able to use all these coordinates to set up graphs. A lot of times you'd end up with a system of equations, which usually you'll do a lot of test points. So you probably have a computer do this part for you. But it'll spit out what the price you should sell it at. So if you wanted to go like really wide, maybe sell the product on Amazon, $4.88 is probably going to be the best price to sell it at, and you should plan to produce 1.95 billion, and you won't waste anything. So that's all good. Any issues with this one? Did we all get the same answer? Let's go to problem 4. This one's a lot bigger. So I'll probably do an extra step of getting all the information out there first. Problem 3. Farmer can buy 4 types of plant food. Each barrel of mix A contains 20 pounds of phosphoric acid and blah, blah, blah. They're giving us some information. I'd actually just try to, the text is just overwhelming at some point. So what I'll probably do is type, let's look at type A, we have type B, we have type C, and we have type D. And they each contain different amounts of phosphoric acid. Versus nitrogen versus potash, which I think is some sort of potassium compound. Yeah, so let's go through. Okay, mix A has 20 pounds of phosphoric acid. It has 50 pounds of nitrogen. and it has 20 pounds of potash. Mix B, 20 pounds of phosphoric acid, 75 pounds of nitrogen, 30 pounds of potash. Mix C, 20 pounds of phosphoric acid, C, 25 pounds of nitrogen, 30 pounds of potash. And then finally mix D, which is 40 pounds of phosphoric acid, 25 pounds of the nitrogen, 50 pounds of the potash. And here's what we want for the mix. So we hired a bunch of scientists to test the soil and realized we need some sort of mixture that contains 540 pounds of phosphoric acid, 650 pounds of the nitrogen, 720 pounds of the protein. How many barrels of each type of food should the farmer mix together to supply the necessary nutrients? Okay, so they also gave us some variables, which if they didn't, that should be something you should do automatically. So think of the thing you want to find, how many barrels, and you set that to be a variable. So x1 equals number of barrels of mix A. And so we have x2, ditto, ditto, mix B, x3 is ditto, 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 mix C, x4 is ditto, 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 mix D. Ultimately, you'd realize that you would obtain a system of equations. So somehow I want to mix A, B, C, and D to obtain 540 pounds of phosphoric acid. So that leads, this column here leads to one equation. 20x1 plus 20x2 plus 20x3 plus 40x4 equals 540. Okay. So per barrel of mix A, I'm getting 20 pounds of this. Per barrel of mix B, I'm getting 20 pounds of that. Per barrel of mix C, I'm getting 20 pounds. Per barrel of mix D, I'm getting 40. When I add up all these poundages, I want 540. By similar reasoning, 50 pounds here, plus 75 pounds there, plus 25 pounds here, plus 25 pounds here. I want that to add up to 650. And then for the potash, I get 20 pounds from the first guy, I get 30 pounds from the second guy, I get 30 pounds from the third guy, I get 50 pounds from the last guy, and I want that to add up to 720. Now, a couple things I can notice here. I do not have a square system. I have 4 variables and only 3 equations, which means I will either have no solution or infinitely many. It's not going to be a unique solution situation. So that's the first thing. I know I'm going to kind of end up with an infinite number of choices, or no choice at all. It's impossible to use this mixture to obtain what you want, and that's what you tell the farmer. In the meantime, let's go about solving this. First of all, I probably start reducing a little bit. 10 goes into everybody here. So maybe let's look at that as 2, 2, 2, 4, and 54. 5 goes into everybody here. That's going to be, or maybe even something bigger. Does 25 go into 650? Yeah, right?
Yeah.
So 25 into this is 2, 25 into that is 3, 25 into this is 1, 25 into that is 1, and 25 into this is 26. Reducing this by tens, 2, 3, 3, 5, 7, 2. So I want to actually solve that system of equations. I can even reduce the top one further. I can divide through by 2. And 2 into that is going to go to 27. Then I want to immediately get zeros here and here. What am I going to do here? I can just take, say, row 2. It's probably outside the camera, but whatever. Row 2 minus row 1. This minus that, 0. This minus that, 1. This minus that, minus 1. This minus that, minus 3. 26 minus that. What is that?
Negative 28.
Negative 28. That makes sense. This and this gives me 14 and then that. Okay. Then I would want to get a 0 here. What I can do is take row 3 minus row 2. This minus that, 0. This minus that, 0. This minus that, 2. This minus that, 4. 72 minus 26. Huh? You said negative 9?
17 minus 26.
No, 72 minus 26.
46.
46? Sorry about that. Now on a test, I probably won't give you anything this big, but there are lessons in this problem that you should pick up. I can ask you things that would require similar strategies. What can we do here? To get this guy to be nice, I want to actually eliminate this. So I'd probably do like the first row minus the second. So 1 minus 0. 1 minus 1, 1 minus a minus 1, 2 minus a minus 3, and 27 plus 28 is what? 55? Row 1 minus row 2.
Wait, where do you get that 2 to be a 1?
Huh?
On the bottom row, the first 2.
Yeah,
Do you want that to be a 1?
yeah, I'm going to get it to a 1. In fact,
Oh, okay.
I can do that now. Because 2 goes into everything here. 2 into 46, 23, row 3 over 2, and 0, 1, minus 1, minus 3, minus 28.
You already mentioned 0 in the
5
third
numbers in
row.
the
Come again?
The bottom row.
Oh, 0. 1 and 2 here. Okay. And what do we want now? I want a 0 here and a 0 here. This one is 0, 0, 1, 2, 23. To get a 0 here, I can just add these. Take row 2 plus row 3. This was this 0, this was that 1, this was that 0, this was that minus 1, this was that minus 3. Okay? And then to get a 0 here, I can take row 1 minus 2 row 3. This minus 2 times that, 1. This minus 2 times that, 0. This minus 2 times that, 0. This minus 2 times that, 1. This minus 2 times that. 2 times that is 46, so 55 minus 46. And that's in reduced or echelon form. Now, what?
Yeah.
Where?
Negative 5.
Here?
Yeah.
Okay, so now what? So now I'll be able to solve this system. Good news is it's not inconsistent, so there are possibilities. Bad news is there's an infinite number of possibilities. What are we going to tell this guy about how to make the mixture for his field? Well, first let's actually solve the system. Notice that this is your x1 column, that's your x2 column, that's your x3 column, that's your x4 column. The x1 has a pivot, so does the x2, so does the x3, so the x4 is the guy that can be your free variable. I don't want to keep writing x4, so let's just call it t. So x4 equals t. Now, what that means, starting from the bottom row up, x3 equals 23 minus 2t. The second row says x2 is going to be t minus 5. The first row says that x1 is going to be 9 minus t. Now that's an infinite number of solutions here, but I would submit to you that not all of them are plausible. Can we start to restrict things here? How do you see to restrict things? Yeah?
Everything has to be greater than 0.
Everything has to be greater than or equal to 0, right? You can't have a negative number of barrels. You're either going to buy none of it or at least one, right? So you're going to have 0, 1, 2, or 3 you're going to have only integer values make sense. So that's what you're going to realize here. Only integer values make sense, non-negative. So, yes, the system has an infinite number of solutions, but applying it to this particular situation, I don't have to consider an infinite number. This is going to suggest that my t must be greater than or equal to 0. That's a given. I'm either going to buy 0 barrels of mixed D or 1 or 2 or 3. That automatically puts a restriction on the t here though, right? What's the restriction here? What can you tell me about t?
It's really slow and a half.
It must be what?
11 and a half or less.
11 or less, right? So that's a restriction, right? So I can go up to 11, in which case I'm buying only 1 barrel of mixed C. But once I bump to 12, once t hits 12, I get a negative barrel. So that's not going to make any sense. So my t must be less than 11. Here, I get that the t minus 5 must be positive, so I also get that my t must be at least 5. And what do I get from here? T must be at least 9 as well. So what kind of, so putting all these restrictions together, what do we get? Viable solutions are obtained for
Shouldn't he be less than 9?
did I put greater than or equal to 9?
Yeah.
Yeah, no, I want less than or equal to 9. So what do we have? So the viable solutions occur for t equals 5 or 6 or 7 or 8 or 9. Right? So the infinite case really reduces to 5 cases in this scenario. I can have I can have A, B, C, D equals 2, 5, well, 1, 2, 3, 4, 5. 1, 2, 3, 4. Getting tight here. 5. So I can have 5, 6, 7, 8, or 9. Now once t is 5, that means x2 is going to be 0. If t is 6, x2 is going to be 1. If t is 7, x2 is going to be 2, 8 is going to be 3, 9 is going to be 4. Any other low-hanging fruit here? So if t is 5, this is going to be, if t is 5, this is going to be 4. If it's 6, it'll be 3. If it's 7, it'll be 2. If it's 8, it'll be 1. If it's 9, it'll be 0. And for the first one, if t is 5, that would be 13. If t is 6, that would be what, 11? I think it's decreasing by 2 every time. 7, 5. Right? So these are the possible solutions. You can buy 13 barrels of this guy, none of that guy, 4 of this guy, or 5 of that guy, or 11, 1, 3, 6, and so on and so forth. And to further refine the situation, other things can come into play in terms of like pricing. Maybe it's way too expensive to buy 13 barrels of this guy. Or maybe you find out about, you know, the guy over here, they have questionable practices at that company. Probably I definitely don't want to buy it here, which is, you know, ethically speaking, I might choose that as the solution. But here we really have 5 situations that could work, and really further discussion will be made for which solution is the best solution. And maybe you might switch between solutions. Maybe their price fluctuations can make this one great now, but probably that one's going to end up better later, and so on and so forth. But in terms of for this situation, that's the best we can do. There are 5 possibilities for what you can do in this situation, and use your discretion over this. So that's something important. Sometimes you have infinite solutions, but technically you don't really have infinite solutions based on some restrictions provided by reality. Questions on this one? Did anyone finish this one? No, we didn't get there. Yeah.
You switch. I think you flip flop pens too.
Did I?
Yeah.
A is going with this, right? Yes, I did flip flop those. Four, 3, 2, 1, 0. Thirteen, 11, 9, 7. Yeah, I wrote them out of order here, so I'm just kind of missing. So if this showed up on a test, probably not this big, your answer will be something like that. The farmer has 5 options for a valid solution, and more information is needed to restrict further. Yeah, so we have a few minutes to spare, but I'd actually stop there. We're going to start with a new topic, not systems of equations, but systems of inequalities and all the sorts of things we can do there. So I think it's really fun. I don't know. I hope you'll have fun with it. But that's what we'll start next time. So I'll see you guys on Monday.
I've always like